Hello. In this video, we're going to take a look at some equations that don't really look like linear equations, but when we go through and simplify them, we will see that they are, in fact, linear equations. So our first one, we've got 1/3 plus 9 over x equals 5/6. So this one, because we have that x in the denominator of the fraction, isn't in the form of a linear equation. Remember, linear equations will always have x to the first power as the only power. Well, this one, we have an x in the denominator, so that means it's raised to the negative power. But, just like we've seen in previous videos, when we have fractions within an equation, we can get rid of those fractions by multiplying each term by the LCD. In this case, we have a 3, an x, and a 6 in the denominator. So our LCD is going to be the smallest number that all three of those go into. And so our LCD for this one, since 3 does go into 6, we can use 6 as our coefficient, and then we don't know what x is, so we're going to let 6x be the LCD. So what we're going to do is we're going to multiply each of these terms by 6x. Make sure, even if you have stuff that does not have a fraction, make sure you multiply all terms by that LCD. All right, so 6x times 1/3, we're going to get a 3 to cancel out. And when we divide out 6 divided by 3, we're going to be left with a 2. We still have that x. On the second term, 6x times 9 over x. Those two x's can divide out, and we're left with 6 times 9, which is 54. And then on the right-hand side, our 6's divide out, and we're left with 5x. All right, we want to, now it actually does look like a linear equation. We want to go ahead and finish solving this by getting all of our x's on one side and everything that doesn't have an x on the other. I tend to like to move my x's in such a way that my coefficient on my x is a positive number. It doesn't matter. We could move our 5x to the left and move the 54 to the right, or we can move our 2x to the left as I have here. It doesn't matter as long as we get that x by itself. All right, so 2x and negative 2x add to 0, so that means we're left with just 54 on the left-hand side. 5x minus 2x is going to be 3x, and then we can divide both sides by 3, and 54 divided by 3 is 18, and so 18 is our potential solution on this, but we always want to check. And so if we check, make sure that we plug back into the original. So I'm looking just at those black writing there. So we have 1/3 plus 9 over the x that we got was 18 equals 5 over 6. We hope that's true. So 1/3 plus 9/18, we can simplify that just a little bit. 9/18 is the same thing as 1/2. And then if we want to add 1/3 plus 1/2, we need to get a common denominator. 2 and 3 both go into 6. So we can write 1/3 as 2 over 6, and we can write 1/2 as 3 over 6, and we do see that 2/6 plus 3/6 is equal to 5/6, so it works out. 18 is our solution. All right, this next one doesn't look like a linear equation. We've got the quantity x plus 10 times the quantity x minus 5 equals the quantity x plus 1 squared. This looks like a quadratic equation. And if this were a quadratic equation, we would want to expand these products as much as we can and combine like terms. So that's how we're going to start this out. We're going to multiply this out. So we can rainbow, foil, box, whatever the word is that you use, we're going to multiply this out. So x times x gives us x squared X times negative 5 is negative 5x. 10 times x is 10x. And 10 times negative 5 is negative 50. On the right-hand side, we have a perfect square trinomial. Remember that if we have, or a perfect square binomial, we have a binomial squared, we're going to get, we square the first one, we do 2 times the first times the second, and we square the last. And so if we square the first one, x plus 1 quantity squared is going to be x squared plus 2 times x times 1, which is 2x, plus 1 squared is 1. And then now we need to get everything on the same side. I'm going to go ahead and move everything to the left. So I'm going to subtract x squared from both sides. I'm going to subtract 2x from both sides. And I'm going to subtract 1 from both sides. And we see x squared minus x squared is going to give us a 0 coefficient on our x squared. We have negative 5x plus 10x minus 2x. Negative 5 plus 10 is going to be a positive 5, minus 2 is going to be 3x. And then negative 50 minus 1 is negative 51. On the right-hand side, everything adds to 0. And what we see is actually a linear equation. So if we finish solving this, we want to get our x by itself. We'll add 51 to both sides to move it across, and then divide by 3, and we get 17. Again, we want to check this. Always check in your original equation. So we have 17 plus 10 times 17 minus 5 equals 17 plus 1 quantity squared. 17 plus 10 is 27. 17 minus 5 is 12. And 17 plus 1 is 18 squared. And 27 times 12 is 324. And 18 squared is also 324. That works out, so our solution is x equals 17. All right, let's look at one more example. This one doesn't look like a linear function, or linear equation. This one looks like a rational equation. We've got fractions in there. But as we've seen and we saw at the first example in this video, we can get rid of fractions in an equation by multiplying by our LCD. Here we have x over x minus 8 plus 3 equals 8 over x minus 8. And so in the denominator there, we've got an x minus 8 and an x minus 8. So that is going to be our LCD, x minus 8. We need to multiply all of those by x minus 8. Make sure that you multiply every piece of our equation, including the 3. Even though it doesn't have the fraction, it needs to get multiplied by that x minus 8 as well. And what we see is our x minus 8 are going to divide out in this first fraction, leaving us just with that x that's in the numerator. We can distribute the 3, and we get 3x minus 24. And then on the right-hand side of the equation, our x minus 8s divide out, and we're left with that 8 in the numerator. Okay, getting all of our combining like terms, x plus 3x is going to be 4x. And then we're going to add 24 to both sides. And 8 plus 24 is 32. If we divide by 4, we will get x is equal to 8 as a potential solution. Remember, always want to check. Plug it back in. We're going to plug in our the solution we got, which was 8. over 8 minus 8 plus 3 equals 8 over 8 minus 8. And we've got a problem here. We get 8 minus 8 in the denominator there. That's going to give us 0 in the denominator. That means that x cannot be equal to 8. Anything that makes that LCD, we can't multiply everything by 0, which is effectively what we did by multiplying all of those by that LCD if x is equal to 8. So 0 in the denominator means that this is not a solution. So we're going to throw this out, and that was the only potential solution. So that means that this equation has no solution. All right, I'll see you guys next time.